All right, welcome everybody. I'm showing you an example problem for acceleration today so that y'all can do that quiz better on study.com. I'm sorry it's taken me a minute. Maybe I'll get it posted here before noon. So our question says, I know y'all probably can't see it over there, so I'm gonna write it out for you. Question says, how many seconds does it take to accelerate an object to 15 meters per second from rest if the acceleration was 3 meters per second squared? I'm putting this over here. So it gave us two velocities. It gave us one to 15 meters per second. And the other velocity it gave us, it says it started from rest. So that's right here. I know it didn't give us another number. One mistake that people end up messing up their physics problems with is they might skim the problem for numbers. Don't do that. You have to read it because it says stuff like from rest, and we have two velocities here. We have a final velocity. This is subscript v sub f and v sub I. This stands for final velocity and this stands for initial velocity. We've got to use the keywords in this question to figure out which one is final and which one's initial. We have to figure out which one it started from and which one it's going to. The from one is the initial velocity. It's one it started from, came from. The to one is the final velocity. It started from the one and then it went to the other. So this one came first and this one came last. So when I write, I'm trying to think which color y'all will see best. I'll try the red here. So if I went from rest, that's VI equals 0. And it went to 15, that's VF equals 15. And it says if the acceleration was 3, and I already messed this up. I didn't start from the beginning because at the beginning it told me what it's asking for. How many seconds does it take? It's asking for time. So I can say time equals blank. I'm going to do the rest of this in the black marker. Now, with this, you can just think about it to figure it out. It tells you the acceleration was 3 meters per second squared. That means 3 meters per second. So each second, this object will speed up by 3 meters per second. Speeds up by 3 meters per second. So at 0 seconds, it'll be going 0 because it says it starts from rest. At 1 second, it'll be going 3 meters per second because it's speeding up 3 meters per second each second. So we just got to figure out how long it'll take to get to 15. After 1 second, it'll be going 3. After 2 seconds, it'll be going 6, speeding up by 3 each second. After 3 seconds, it'll be going 9. After 4 seconds, it'll be going 12. And after 5 seconds, it'll be going 15. So our answer ought to be 5. When we have other numbers that aren't as easy, like decimals and stuff like that, it won't be as easy to think about this the way that I just did. And that's what the formula is for. So let's make sure that we're right with that 5 seconds and use the formula. All right, acceleration is 3. So I wrote the formula, just the formula. It's very important to me, and I think it'll be very useful to you to keep everything organized just like this. First step, write just the formula. Don't plug any numbers in yet. And I do this for every question, especially when we get like our velocity practice, I guess I told y'all, that was 3 variables. Now we're at 4, and we're going to 5 pretty soon. And there's one that we'll use that has 8. So it's very important to stay organized. This is how I recommend to do it. So acceleration is 3. First step, I wrote down my formula. Second step, I wrote down my variables from the question. And third step, I'm rewriting the formula with everything plugged in. So acceleration is 3 meters per second squared. Final velocity is 15. Initial velocity was 0. And time was, we don't know. Okay, this is the tricky one. Whenever you have time in the denominator, whenever you have anything in the denominator that you're trying to solve for, you need to get it out of there. It makes it really difficult to solve if you try to leave it there and start doing stuff to try to solve it. First step is to get it out of there. So I'm going to make it cancel. It says divided by t, and I'm multiplying by t. To make it cancel, I got to do the opposite. And I got to do it to both sides because otherwise this equal sign isn't true. So now I have 3 meters per second squared times t equals, let's see, there was a t on the bottom and t on top. Also, 15 minus 0 is 15. So I'm simplifying that top part to just 15 because 15 minus 0 is 15. And now it might be easier to see that our answer is going to be 5 because we know 3 times 5 is 15. We got a 3 and a 5. So let's finish this up. It says 3 times t equals. I need it just to say t equals, and then I'll say t equals this many seconds, and I'll be done. So I need to make this 3 cancel for there to be just this t now. It says t times 3. So I need to do the opposite to make that 3 cancel and divide by 3. That's meters per second squared. And one on top, one on bottom. I got to do the same to both sides, otherwise the equal sign is not true. 3 meters per second squared. Okay, 15 divided by 3 is 5, so we did it. And if you really want to, you can mess with these units. You don't have to. You can just say that time is supposed to be in seconds, so I'm done. But if you want to check your answers this way, this is an option. There's meters on top and the meters on bottom. And there's a seconds on top. There's seconds squared on the bottom, which is s times s. So we're going to make it just s because we got one s up there and we canceled one of these s's, and now we're left with just seconds. So that helps us check our answer. But you don't have to worry about the units there if you don't want to use. As long as you put it down here, time is 5 seconds. You know it's seconds because time is supposed to be in seconds. And there's an example. I hope that helps you all solve the problems on the assignment.